Good afternoon, candidates. At this point in time, we call you candidates. I hope I'm right. I think those who are left here are those who are doing physical science and those who are not allergic to physical science. Right, so before I continue, right, my name is Ozias Marufu, but I guess you call me Mr. Marufu? I guess so, right? I was just told to summarize the whole of paper one like now in 2 hours. So I'll be moving not at a speed of light, but a little bit less than that, right? So then at the end of the session, right, I'll give you the worksheet which you can go through and revise on your own. Right, before I proceed, I want to talk about misconceptions which are occurring at your school. For example, they say, today we are writing physics paper 1. Then on a Monday, they say we are writing physics paper 2, right? Some of my colleagues say that. So now you go and correct them. That paper 1 is physics and paper 2 is chemistry, right? You call them physical sciences because it's a combination of physics and chemistry, right? Before I proceed again, any number multiplied by 0 is what? This is what we call a concussion test. In soccer, when Liverpool is playing Arsenal, right, when they clash their heads, right, you see doctors rushing in to check whether these people have been affected by their collision. And usually they ask the Arsenal player, which team do you play for? Then the Arsenal player will say, I play for Liverpool. Then they can see that there's a problem. Then they take him out, right, to the hospital. So this is a concussion test to check whether the people I'm dealing with now today are the right people. That's why I said it's an academic concussion test. Right, my slides, I don't know whether I should call them slides. Yeah, this is Newton. As you can see, it's a familiar name. I can calculate the motion of heavenly bodies, but not the madness of people, right? So I can continue. Right, without wasting time, because I'm not given much time here, we are going to deal, I'm going to highlight and rush through mechanics, right? But before I go there again, you must know that in your question paper, you are supposed to answer all questions. You don't choose, like I think in English, whereby section A, answer 2 questions, or business studies. In physical sciences, you answer all questions, right? Then I also want to highlight to you that I don't understand learners whom, when they don't get the answer correct, when they feel their answers is wrong, what do? They leave multiple choice blank, as if what they've answered is correct. So that is another problem. Why don't you just put A or B? Right. Again, I want to warn you, there are no 2 answers in multiple choice, whereby you say A or B. That has never happened. So don't ever think that there is going to be A or B. If there are 2 answers, then what do you call it? The one which they sent after some time to correct that will be corrected. So again, when we're talking about mechanics, right, we're going to talk about Newton's laws, vertical projectile motion, which is VPM, right, momentum and impulse, work energy and power, right? That is their weighting, right? So mechanics on its own, it's 65 out of 150, contributing about 43.3% of the paper. So when you are looking at that paper, right, you must know where to put more weight. You must know where to put more emphasis, and you must budget your time very well so that all of that is covered, right? Based on physical science exam guideline, DBE, right? What they are trying to say here is whatever definition you are going to use is going to be from the exam guideline. You are not going to manufacture definitions. You are not going to dream about definitions and write that dream in the exam paper. So the examination guideline is going to give you directions, right? I don't want to concentrate about what is mechanics 1, what is mechanics 2, because that is not very important to you. What is important is for you to answer the question. So all in all, right, am I audible at the back? Is my voice clear? So that I feel that I'm talking to people who are understanding. Is my accent okay? Yeah. Because even if it is not okay, I'm not going to change it, right? So let's talk about paper 1. So this is the overview of the whole paper here, whereby there's mechanics, as I said, 65, then wave, sound, and light is 15, electricity and magnetism is 55, then matter and material is 15. So there is no point in time whereby all of a sudden you find that matter and materials is 20 marks. That one won't happen. So this is to just remind you again, where do we have the most marks? When I go to the next part, which is mechanics, the weightings in mechanics there, you can see Newton's laws, it's 18 marks, plus or minus 18 marks, then vertical projectile. We are saying plus or minus 1 mark, so that when you see 14 marks or 15 marks in the exam, you don't say my name, right? So now momentum is plus or minus 14. Then lastly, work energy and power, right? I'm going to rush through the concepts. Right, these are the main concepts. Unit conversion, that one is very common. Components of a force, like the horizontal component, vertical component, and so on, right? So the rest of those main concepts, we are going to meet them as I move with my slide in that order, right? Right. This is straight from the examination guideline. So you are supposed to state Newton's first law, which is supposed to be the law of inertia. And we talk about Newton's first law. What are we talking about? We are talking about forces in equilibrium, right? We are talking about balanced forces. We are talking about objects moving at constant velocity. So F net is 0, right? When we go to the right, I said it is also called the law of inertia, right? Inertia, I'm not going to define that, although it is a property, right, of a substance. It's a property of a substance, the resistance of an object to any change in its state of motion or state of rest, right? And mass is actually a measure of what? Of the inertia, right? Under this Newton's second law again, right? Here we are talking about resultant force or net force, right? And under these topics, you'll be required to draw force diagrams. Force diagrams, you know by now that the object is there, right? And free body diagrams, the object is represented by a dot. And sometimes if they say 3 marks, it means 3 forces are required, right? If they say 3 marks, but there are only 2 forces, it means you have to put into consideration the length of the force, the size of the force. So the bigger one, you have a longer length than what? The shorter one, in that order, right? A single object moving in a horizontal plane with or without friction, on an inclined plane, again, moving on a vertical plane, right? Those are the concepts, right? Whether friction is there or not. 2 body system, both of them on a horizontal surface, both of them, right? Experiencing friction or not, right? Then we have a situation of which I'll show you as we go along, right? Then I'm going to just talk about Newton's third law. Newton's third law, right? Action, reaction forces in that order. Where you are seated there, your buttocks are exerting a force on the chair, and the chair simultaneously is exerting a force equal in magnitude, but in opposite direction. So Newton's law is acting on your buttocks, right? Let's proceed. I just want to remind you that listening is a skill. Listening is a serious skill. If you talk while least I'm talking, it means you are lacking that skill. And if you lack that skill of listening, your concentration and your focus is also affected by that. So as I said, it's a skill. If you don't have it, start developing it, because next year you'll be at university. I guess whoever is here wants to go to the university, unless if there's a mistake. Again, I must also, I'm preaching to the people who did not get 100% in paper 1 in the prelim. If we have some people who have 100%, then I'm going to have a problem. Okay, right. So, Newton's law of universal gravitation, that is the next one, right? I'm not going to state the laws. Those laws are in the examination guideline. As you move along, when you are driving or when you are at home, you can give your maid all the definition, or your garden boy. The garden boy will be checking whether what you are saying is exactly what is written in the exam guideline. So it's proper. It's proper, you know, the definitions in all concepts, in all topics. And in this case, Newton's law of universal gravitation, usually they ask you about the law itself. They might ask you about weight and mass to define that, right? The formula is as it is given there, right? Right, in a nutshell again, talking about the laws, right? An object will remain at rest in the first scenario in Newton's first law unless a net force or unless a non-zero resultant force acts on it. Then, or else an object will remain in constant speed or constant motion unless acted upon by a non-zero net force. For example, what happens when you don't have a seat belt with you and the car is moving at 100 kilometers per hour, then there's a sudden stop when now you are going to continue that speed. Because why? Because the seat belt is going to act as a what? As a net force. Am I right there? Yes, you are allowed to criticize me, but you must be very careful in your criticism, right? Now, Newton's second law, here we have a resultant force, right? right? A force causing an object to accelerate. As you can see the diagram on my left-hand side, acceleration being inversely proportional to the what? To the mass, right? Newton's third law. If I come this side, I don't think I'm going to talk about which one is the independent variable. The gradient of this, I think you did in grade 11. What does the gradient of this graph going to give you? What about that one? That one you cannot get the gradient, but this one, right? Which is a straight line. Action-reaction forces, I think I've just talked about that. So we go to Newton's universal gravitation in that order, right? Right, the same concept applies, the proportionality. The proportionality we are talking about, that the force, right, is inversely proportional to the square distance between the centers, between their centers, right? We are going to talk later about Coulomb's law, right? Right, force being directly proportional to the inverse of the what? Of the square distance in that order. Graphically, this is what the principle is saying in a nutshell. I'm talking too much. 1.1. 1.1, talk to me, boys and girls. You see the advantage of talking. The people will get a wrong impression of you. They will think that you are intelligent, which won't be wrong. I don't want people to raise up their hands. You can stand and talk. Should I come with this? No, I'm not coming there. Stand and talk. I must check my time here. I must finish. I've got a long way to go here. Talk to me, boy. Can you just say A or B? C. C. In C, we can see that the forces are in equilibrium. It's a closed triangle, right? Why is A wrong? Come again. The head to tail is wrong. Why is D not the answer? Why is D not the answer? There's a resultant force, right? Is the tail to head diagram correct? It's also wrong. So in this case, do we have a tail to head diagram, or we have a tail to tail, or we have nothing? Do we have tail to tail? Where? Right, same applies here. Without wasting time, 1.2 again, which one is at constant velocity? We expect that in a closed triangle as well, right? Do we have anywhere where we have tail to head diagram? Yes. Which one is that? A is tail to head. Yes. I'm confused. There is tail to head in A. Yes. Anyway, what is the answer anyway? Then let me not ask many questions. Right, let's move. I thought there was no answer. 1.3. 1.3, boys and girls. A net force F is applied on an object of mass m kg and causes an acceleration of a meters per second squared when the net force F on the same object is doubled, the resulting acceleration in meters per second will be, is it going to double as well? Is it going to double? Is it going to double, boys and girls? Are you sure about what you are saying? So can we take our C as the answer? Let's proceed. Let's talk about, you see my numbering. I don't worry about that one. Don't worry about my numbering. You see, you know very well that a beautiful girl is not always the best, isn't it? Let me not be sexist. You know that a handsome boy is not always a good one. Yeah, I can see some are feeling guilty now, right? Right, here we are looking at normal force. There are 4 ways of normal force. Normal force on a horizontal plane. We talk about mg, right? Right, normal force on an incline, it's mg cos theta, right? Then we talk about normal force when an object is being pushed at an angle, or when an object is being pulled at an angle. In this scenario, are we talking about pulling or pushing? Right, so can we say the force is in the same direction with Fg? Can we say it is opposing normal force? Can you see the force F? Is it in the same direction as gravitational force? Or vertical component? Someone is correcting me like that, right? Which is a very good thing to be corrected, right? So we are talking about the vertical component. Vertical component, right, of F is in the same direction with Fg, right? And it is opposing what? Normal force. If we do that, can we get the answer quickly? Which is, right. So now, in a situation, you said B, right? Can someone explain? Can someone give me a hint of C? What is happening in C? Is it still a push? Is it a pull now? Right. So, for C, it's now a pull, right? So, in terms of normal force, we have already covered a chunk, right? Let's talk about 1.3. Talk to me about 1.3, because now we want the magnitude of normal force on an inclined plane. On an inclined plane. Am I right? If I see people laughing, maybe it's a declined plane, not inclined. Because I said inclined, maybe when you see there's a declined plane. Talk to me about this one. People are saying D, because the formula I know is mg cos theta. Is mg cos theta in concordial agreement with D? Is mg cos theta in concordial agreement to D? Concordial agreement. That's why I love English, right? So your answer is D, which is mg cos theta, right? And now let's go to the next one. We have a situation whereby we are in a lift. It's a situation whereby we are in a lift, right? Or it's a bathroom scale. How nice is this? How nice is this? Or we are in an elevator, but when I are on a bathroom scale. Also, I'm sober, right? Now, so a person stands on a bathroom scale in a stationary elevator. The reading on the scale is 490. When the elevator is in motion, the reading on the scale changes to 470. You must know that when an elevator is moving, it is accelerating, right? It is either accelerating upwards or accelerating downwards, right? That part is covered, right? You know very well that there are two forces here, normal force and Fg. Right, when Fg is greater than normal force, where is the lift going? Is the lift going down? Or let me talk about when it is stationary. When it is stationary, the reading on the scale is 490. What will be your weight? Yourself? 490, right? That will be your true weight, right? When you start moving now, it's no longer your true weight. When it moves up, do you feel heavier? Yeah, because I want to check whether there's a lift there. I want to take some people there. I might be talking to people who have never been in a lift. So, for some other reasons which I don't know, because so now without wasting time, boys and girls, right? As I said, when the elevator is moving up, it means the normal force is greater than Fg, and that's when you feel to be heavier than your actual weight, right? Because of that, the lift will be accelerating upwards, right? When Fg is greater than normal force, that's when you feel lighter than your normal what? Your normal weight. So under the circumstances, direction of motion so we can use the elimination method. What are we going to eliminate there? We are going to eliminate what and what? We are going to eliminate C and A, right? So we'll be left with what? B and D, right? You can see in D, there is some form of madness there, right? Direction of acceleration, it's upwards and then downwards. So that one, you can see that it's a criminal answer. So we are left with what? With B, right? Are we together? We have to be together. Right, 1.1, as I said, my numbering is, it's haphazard because I want certain concepts. I want certain concepts to be addressed here. A bucket is at rest. Which one of the following is the reaction force to the weight of the bucket as described by Newton's third law? The bucket is on a table. First, you have to understand the meaning of the weight of the bucket. Weight is the gravitational force exerted on the bucket by the what? By the earth, right? Talk to me about the answer. Yeah, some are saying A, some are saying B, and some are saying C. We don't want such. There's only one answer here. Otherwise, others will end up saying E, and E is not there. So as I said, the weight is the force of the earth on the what? On the bucket, right? So it means the bucket should also have a gravitational force exerted on the what? On the earth, and that force is what? Upwards. Can we take B as our answer? Excellent. You see why I'm saying excellent? Because some have never been told excellent. From preschool. From preschool, now you're about to finish school. So I'm very worried. But I don't want you to go like that. Planet X. This will need some form of calculations, right? Can I give you 2 minutes to do that? While least I am looking for water, which I am not given here. Hey, our life is tough. Okay. I can see if water even when we are not talking. Myself, I'm talking, and I don't have water. Okay, the water is coming. Zoom how? Right, let me put on glasses. Have you ever seen a professor without glasses? That one is not a professor. Professors have. Right, I'm trying to zoom so that those at the back can see as well. I tried to zoom. I tried. Where's my mic again? I want to. Right, I tried to zoom here. Right, may we proceed? Are we dealing with the formula, which one? Are we dealing with acceleration, capital letter G and M over R squared? Are we dealing with that one? If we are dealing with that one, it means the mass is twice, is times 2. Is the mass times 2 now? Right, then what is your 1.5 is 3 over 2, right? That one is squared, right? Am I right? Right, so mass doubled, right? Divided by 3 over 2 squared, right? 3 over 2 squared, I don't know whether it will give me 9 over 4, right? 2m, is it? 2m over 9 over 4. Let me ignore the m. Then it's 2 divided by 9. And what are we talking about? Talk to me about the answer here. The answer is A. If we agree on that, I think it's magnificent. It's magnificent, right? Right. Boys and girls, we are not going to do any calculations here, but this is one scenario whereby you are supposed to highlight such words like constant speed there. Highlight such words like constant speed. And under the circumstances, when we talk about constant speed, we are talking about F net. F net being equal to what? To 0, right? Or we might be talking about an object moving at constant velocity in that order. Right, free body diagrams, I can see that we have 4 marks there. So after checking, do you think we have 4 forces there? Yes. That's beautiful. If we have that, now let's proceed. We can talk about the horizontal component, which is F cos theta, right? We can talk about the vertical component, which is F sin theta. And when we talk about normal force in this case, it's a pull, right? If it is a pull, right, what is your normal force in a nutshell? Normal force is equals to what? Is it weight minus Fy? Do I agree on that? So in a nutshell, Fg, which is weight, the vertical component of that force, right, is in the same direction with what? With normal force, right? And it is opposing what? Fg. I guess I am clear on that. So looking at that, this is what I just wanted to highlight there. That is how you find normal force. Right, if you have normal force, now it's much easier to find a frictional force because they are talking about the what? The coefficient. They are talking about the coefficient of what? Coefficient of kinetic friction, right? With that, you are able to calculate frictional force. Your frictional force, which is your Fk, is coefficient of kinetic friction times normal force. Am I right, boys and girls? Right, thank you for that. Right, you see, I always make sure. Thank you for that. Right. I said we might have a situation like that, 2 objects, right? The other one on a horizontal plane, right? The other one is hanging like that. The good thing about that is that it is at constant speed. If it is at constant speed like that, it's easy to find tension, isn't it? Which mass are we going to use to find tension there? The 2 kg one, right? Right. So we assume the object is going upwards, right? So tension is upwards. Minus Fg should give you 0, right? Now let's talk about this topic whereby every object, you have to draw a free body diagram for every object there, right? And why should you draw a free body diagram? So that you are very aware of all the forces which are acting on the object. At the end, you will be able to use the quadratic equation to find the acceleration, right? F net is equals to mass times acceleration. Those are free marks they decide to give you. F net is mass times acceleration. Then the next stage, you substitute the mass. They give you another mark for that. How difficult it is to fail this topic. It's very difficult, right? You continue like that. But I wanted to talk about these 2 free marks, which are supposed to be given to you, which are for free, right? And However, you cannot just say F net is equals to mass times acceleration and substitute nothing. You can actually say F net is mass times acceleration and substitute rubbish. You still get 1 mark for the what? For the formula. Right. Now, boys and girls, 2.2. Do we have 5 forces acting? If you agree, then we pass. Do we have 5 forces acting? Beautiful. Beautiful. Right, so this is another scenario, right? Then the scenario we have, this is another scenario again, whereby the other object will be on an inclined plane and the other object will be what? Will be hanging. Hanging. Yeah, I told you about my pronunciation, hanging. Vertical projectile motion, boys and girls. The second part. That definition which you are seeing an object which has been given an initial velocity and then it moves under the influence of gravitational force only, right? Let me see the conception here, the misconception rather. So some learners will say an object which has been given initial velocity and moves only under the influence of gravitational force only. Right, you are using only twice. Right, an object has been given initial velocity and moves only under the influence of gravitational force only. Right, do you call it tautology in English? We don't want tautology. Free fall. Free fall is the next one. This one is a motion. Projectile, we are talking about an object in that order. Right, now we talk about what is required in this topic, whereby you are going to use equations of motions and velocity time graph, free falling body object, an object thrown vertically upwards, an object thrown vertically downwards, bouncing ball, right? Displacement time graphs, acceleration time graphs, an object thrown upwards. One which is thrown upwards is an initial velocity. One which is dropped is 0 initial velocity. One which is released is initial velocity of 0. Dropped, released, falls, initial velocity is what? 0. Right? What I must remind you again, acceleration due to gravity, which is A there in that formula, at maximum height, it is constant. In terms of direction, it's always downwards, and the magnitude is 9.8 meters per second squared. Why am I repeating this? Because people did not get 100%, right? So now, again, we are at maximum height, right? That's where we have our final velocity being 0. What else is 0? What other variable is 0 at maximum height? Final velocity at maximum height is 0. Right? My next question is, which other variable which you know is 0 at maximum height? Acceleration is constant, 9.8 meters per second squared. That is the magnitude. In terms of direction, it's always downwards. Whether the object is going up, whether the object is going down, the status quo remains. Talk to me. Talk to me about the other component or the other variable. Especially those who are sleeping, you have all the answers. If you find yourself sleeping, you have too much information. That what I'm saying, it's over-revised in your head. You understand the word over-revised? Your head is saturated with information. Just like humidity sometimes is saturated. The atmosphere is saturated with humidity. So when your brain is saturated with physics, whoever is going to talk in front of you, you are going to sleep. Because whatever that person is going to say, you know it. How sweet is that? I think I should ask for blankets now for those who are sleeping. Kinetic energy. Kinetic energy. Is it zero at maximum height? Because there's velocity, right? Half mv squared. Is momentum also zero at maximum height? Right, this is what I wanted to hear from candidates. You see, we've promoted you to candidates. Right, this is what I wanted to hear from you. Right, so kinetic energy, then we talk about momentum. Those are also the variables or the quantities which are at what, which gives us a magnitude of zero at maximum height, right? A ball is thrown vertical upwards and returns to the same position from where it was shown, right? If I'm looking this way, my left-hand side, there's left-hand side, which is separated by this, right? Then my right-hand side, right? What is the difference between the left-hand side and the right-hand side? Direction, right? So a ball is thrown vertical upwards. Which direction is taken upwards as positive, left or right? Right, left is taken upwards as positive, right? Then on the right-hand side, upwards has been taken as negative. The same applies to velocity time graph, right? You can see that velocity decreases, and you can see this part and that part, the length, these two lengths are of equal size, because the object is coming back to the what? To the same position in that order, right? Acceleration time graph, that's why they no longer ask you that, because everyone can answer that one, right? So acceleration is negative when you take upwards as positive, and it's positive when you take downwards as positive or upwards as negative. Then a ball is thrown upwards from a height h and returns to the ground, right? This is the graph which is illustrated, and upwards has been taken as positive, right? Then a ball is thrown upwards from a height. Let's say you are at the top of a building. You are at the top of a building there. You can see on my left-hand side, the position time graph, the height, the top of the building is taken as what? As zero reference, right? So you are at the top of the building. The left-hand side is depicting that the height is taken as zero as reference. So you are on top, then you take that top position, you are on top of the roof, then you take that to be what? To be the reference point. Here, you are standing on the ground. You are seeing the top of the building above you, right? So you are taking the ground as the what? As the reference point. In a nutshell, you are taking the ground as zero in that order. Is that clear? Right, let me proceed. Right, when we come to the velocity time graph, right, you can see now this part here, this part is now longer than the first part. What is on the negative side of the Cartesian plane is longer than what is on the positive side, provided that you have taken upwards as what is positive in that order. Right, let me rush here. Right, like what I was saying, I'm going to summarize that. Which part do I feel is important? At the maximum or highest point, the velocity of the object is 0. The y-intercept of a velocity time graph is the initial velocity of an object. The x-intercept of the velocity time graph gives the time taken to reach maximum height. Then the gradient of the velocity time graph will give you the acceleration. And the area under the velocity time graph will give you displacement. Right. This is a reminder of what you did in grade 10. Right, bouncing ball, downwards is taken as positive in that order. So what I'm showing you now is a reminder of what you should go through right before the exam. A hard tennis ball is dropped vertically downwards to the ground and then it bounces back in that order. Right, downwards is taken as positive. Right, in that on the left hand side. Right, what else are we supposed to see is the contact time is negligible, right? It is too small to be measured, right? So in a nutshell, contact time with the ground can be taken as 0, right? Then on the right-hand side, negative, downward is taken as negative in that order. Right, position time graph there, right, the same scenario. Maximum height, initial position is 0 there, right? Where the ball, the source, where the ball is coming from is taken as the reference point, right? And this one is indicating on the left-hand side, we are taking the point of reference where the ball was dropped to be the reference point. Then the position time graph, ground is 0 reference. Then this is your ground is 0 reference in that order, right? Graphically like that. So let me move. Now we have a soft ball. The scenario is the same, but now the only difference is this contact time. And sometimes they ask you to calculate what contact time. And in this order, in that scenario, we can say collision is also what? Elastic or inelastic? Collision is inelastic in a nutshell, right? So a ball is dropped, right? This is my resting time. A ball is dropped from a small height above the ground, right? Ignore air resistance. The following pairs show physical quantities associated with the ball while it is falling to the ground. In which one of these pairs will both quantities change while the ball is falling? So there is mechanical energy and weight, kinetic energy and weight, and kinetic energy and momentum, gravitational acceleration and kinetic energy, right? Then in multiple choice, we always eliminate something, right? So while this time, right, I'm here, boys and girls. Right, what can we eliminate there? A has been eliminated. C has been eliminated. And D also. That's crazy. Okay, so let's proceed then. So what has not been eliminated is the correct answer. Oh. Right, talk to me, boys and girls here. Tell her to talk to me. You don't know her. Call her X if you don't know her. Yes.
Can I ask something about acceleration time graph? So in terms of the softball, when we draw the acceleration time graph, do we show like that it is bouncing, or we just draw a straight line like that?
It cannot be a straight line. There is it stopped sometime, so it's not straight like that. It goes down then up.
So do we do that for a softball or any other ball for as long as there is a bounce?
Come again on that question.
Do we do that whatever spike whenever there is a softball or any other ball to show that there is a bounce?
It works for a soft ball, or it works on a hard ball being dropped on a soft surface. You get the point? Yeah. So those can be two scenarios, yes.
So when drawing that spike, does it have limitations or it can cross the x-axis?
Do you think it can be less than 0? When you take downwards as positive, when it passes, you are saying it passes below the line, the 0 line. It should not pass if you take downwards as positive. Is that so? Or you don't agree? So I don't think it can be below 0. It can only be 0. Then up again, straight. Right. I hope I've answered you. I'm trying, boy. You know, some teachers will run away if you ask a question. Or they'll give you his homework. Right, can you see that question there? What are we eliminating? We are eliminating A on what basis? Because a position is.
Because they use the straight lines and this. So those lines show the gradient of the graph. The gradient is a straight line. It means the ball is moving at constant velocity. And we know that when a ball is projected vertical upward, it can move at constant velocity. The velocity is changing. The graph will be a straight line.
Thank you, boy. At least now you've opened the floor. You have opened the floor. You have shown everyone that you are allowed to talk. Some are not very sure. Some are not very sure whether they are allowed to talk or not. Show them, boy. Right now, a position time graph, when I'm talking to grade 10s or street kids, it cannot be straight lines. That's what I tell them. Because for you to have a graph like that, it comes from the fact that you have actually drawn a position time graph. When you throw a ball up, it does not come down straight like that. As if it is a, what do you call it, the gas canister. That one, if it goes up, it comes back where you are when it explodes. That's how dangerous it is. That's why they put the gas containers outside, so that it can go up and come back and get to its position again when it is from there. Sometimes I won't tell you whether I'm lying or telling the truth when I are going to figure it out. So now, A and B, we kick them out. Then we are left with C and D. And then talk to me. I hope we agree on C, right? Because the ball bounces back to the same height in that order. Right? 1.2, without wasting time. At which time does the ball reach its maximum height after the first upward bounce? A ball is dropped. The ball is dropped, right? At which time does the ball reach its maximum height after the first upward bounce? Yes, girl? She's saying Q. And no one is arguing with her. Thank you, girl. At least you have represented girls. Girls are allowed to talk also, right? Thank you, girl. Even those without glasses, she has glasses. So even those without glasses, you are allowed to talk, right? Right. What I usually talk about is there are free marks like these ones whereby you are just asked to define free fall or projectile, right? These are free marks. We call them lower order questions, whereby every Tom, Harry, and what is the other one? Right, can answer, right? So take advantage of that. Don't make mistakes. Make sure. You know, some people finish 30 minutes before exams, before the exam is over. Some finish an hour before. But the person who said that paper is so sure that you need 3 hours. When now you take 2 hours. You can see there's a problem. Whether the problem is the paper or you, I don't know. Right? Right, so calculate the time taken for the ball to strike the ground. These are the easy marks which are given to everyone. Magnitude of the velocity. What do I want to say here? When there's magnitude, there's no need. There's no need to what? To give direction. Now they are deducting marks if you give direction when they say magnitude. Right? You can only give direction when they say calculate the velocity. Right? A position time graph, we've seen examples of that. Right, this one is a position time graph again.